Good day, everyone. My name is Bert Marius M. CAPALAC, and I'm here to talk about the language of mathematics. Now, the language of mathematics can be described in three words. The language of mathematics is defined as number one, precise, number two, concise, and number three, powerful. Now, let's define this thoroughly. First, the mathematical language is all about precision. It is precise, which means that every mathematical term or symbol has a clear, unambiguous meaning. For example, the symbol of pi always refers to the ratio of a circle's circumference to its diameter, regardless of the context. Now, why? Because precision eliminates misunderstanding, ensuring that mathematical statements and equations are interpreted consistently across different fields and cultures. Mathematical language is concise. This means that mathematics conveys vast amounts of information using minimal notes or words. Now, this means that symbols, equations, and formulas replace lengthy verbal explanation. Now, number three, mathematical language is powerful. Mathematical language has the ability to describe and solve a wide variety of problems, from abstract theoretical concepts to practical real life applications. Now, let's talk about the difference between mathematical expressions and mathematical sentences. The difference between mathematical expressions and mathematical sentences lies in their structure, purpose, and ability to convey complete ideas. A mathematical expression is a combination of numbers, variables, and operations that represent a value or a concept but do not form a complete statement. Now, to further elaborate this, we have an example. This here shows an example of mathematical expressions. As you can see, they do not include a verb or a relational operator. This means that they do not have these symbols to make a complete statement. Now, let's talk about mathematical sentence. A mathematical sentence is a complete, meaningful statement that includes a verb or a relational operator, which allows it to be evaluated as true or false. Now, the key feature in here is that it expresses a relationship between mathematical expressions or values. To understand further, these are the examples of a mathematical sentence. Now, to sum up, the complete difference is that a mathematical expression is a building block that represents a value or a quantity but lacks complete thought because they do not have this relational operator or operation. Now, a mathematical sentence is a complete statement that expresses a relationship, claim, or a question and can be evaluated as true or false depending on the value and the equation. Now, to test further our knowledge about the difference between mathematical expression and mathematical sentence, let's have these five equations to see if they are either expression or a sentence. Number one, we can clearly see that it is an equation because this does not include a relational operator and it cannot be evaluated as either true or false. Number two, it is a sentence. But why is it a sentence? This is a complete statement with the relational operator equal sign and can be evaluated as true. Now, number three is an expression because this represents a value but lacks relational operator, which could be an equal sign or greater than sign. Now, number four is also an expression because this is a constant value and not a complete statement. Now, number five, this is a complete sentence, a sentence because it has a relational operator which is equal sign that can be evaluated as true, or in other words, it is a commutative property. Lastly, let's talk about conventions in mathematical language. Conventions in mathematical language are standardized rules and practices used to ensure clarity, precision, and consistency in mathematical communication. These conventions help with mathematicians understand and work with each other's ideas without ambiguity or confusion. Now, it is conventional to write the number first before the letters. If in case the letters are more than one, you have to arrange the letters alphabetically. Now that we know about that, let's answer these equations and solve them in the most conventional way. For number 1, the answer is this because the variable is written after the radical for clarity. Number 2, the answer for this is this because numbers are written first, followed by variables in alphabetical order. Number 3, the answer for this is this because numbers are written first, followed by variables in alphabetical order, as what I have mentioned earlier. Number 4, the answer of this will be this one because variables are arranged alphabetically with their powers. Now, number 5, the answer will be this because the numbers should be written first, followed by variables in alphabetical order with their powers. Now, I hope you have learned a lot about